Good morning, everyone. A very good morning. Shall we begin the session? Yeah, today's topic is part number two way of finish in the last class, part number one, that is the database analysis. Next is the part number two, that is the database design. So let's start with the part number two. So this database design our database systems are designed to manage large bodies of information, and these large bodies of information do not exist in the isolation, but these are the operation of some enterprise whose end product may be the information from the database, or that may be some device or service for which the database plays only a supporting role. So that is provided with the database design. So shall we start? When we talk about the ER model, that is also a part of the database design. Yeah, so instead of representing all the data in the table, it differentiates between the various objects. That may be entities, that may be a relationship among these objects. That is the first step in the database design. So database design means whenever I want to represent, whenever I want to design the database concept or some device for which the database plays a supporting role. So if I'm talking about the relation database design, that is the design of the relational schema. And there are also principles that is used to differentiate the good database design from the bad one. That is formalized by means of the several normal forms, that is between the inconsistency and the efficiency of the certain queries. And when I talk about the design of a complete database application environment that meets a need that is based on web-based interface to the applications. Now let's start with the chapter number 7, that is the database design and the ER model. Now, can anyone tell me what is the meaning of ER model, or why we use the ER model? So whenever I want to model, whenever I want to design, I want to make the database schema and study how queries and updates are expressed, we are using the ER model. So chapter number 7 is database design and the ER model. Now we now consider how to design a database schema in the first place, and in this chapter we focus on the ER model. We focus means we mainly aim is ER model that provides a means of identifying entities that is to be representing in the database, and how the entities are related with each other, how they are used with each other, and ultimately the database design will be expressed in terms of a relational database design and the associated set of the constraints. And how these constraints are captured in that design, that in detail how good or bad database design will study the process of creating good design methods using a broader set of the constraints. So these two chapters cover the fundamental concepts of a database design. Now first step is overview of the database design. So the task of creating a database, of task of developing a database or creating a database application, that is a complex one, involves designing of the database schema, design of the program that access and updates the data, design of a security schema to control the access to data. So this is the overview, that is what is the design process, how it follows up, and how it involves with the database schema, how it involves with the design of the program that access and update the schema, who are the users that plays a central role in the database design. So in this chapter we focus on the database schema, although we briefly outline some of the other design tasks also available in this chapter. And the design of a complete database application environment that meets the need of an enterprise being modeled also requires attention to a broad set of the issues. So these additional aspects of the expected use of the database influence a variety of the database choices at the physical, logical, and the view level. So there are three levels, or there are three choices. One is the physical, one is the logical, and one is the view level. So first part is the design phases. What are the various design phases by which application will be developed? So for the smaller applications, it may be feasible for a database designer who understands the application requirements to decide directly on the relations to be created. What are the various relations that is to be created? Their attribute, the constraints on the relation. However, such a direct design process is difficult for the real world entities. So such process is very much difficult for the real world entities that may be representing in the high level fashion that can be understood by the users. Then translate the requirement into the lower level of the design. So first of all, it goes to the physical, conceptual, and the logical. And the high-level data model serves the database designer by providing what are the various issues, what are the various database users who carried out the data with the content, who carried out the data with the designer by providing a conceptual framework to specify in a systematic fashion what are the requirements of the database users, how database structure will fulfill the requirements, how to use the database structure. The first part is initial phase of database design is to characterize fully the data needs of the prospective database users. And database designer needs to interact extensively or extensively with domain experts and users to carry out this task. And what is the output? That is the specification of a user requirement. So while there are the techniques for the diagrammatically representing user applications requirement, so we focus on the textual description of the user requirement that is used with the designer that chooses a data model. By applying the concepts of the chosen data model, translate these requirements into conceptual schema of the database that is developed at the conceptual design phase that provides a detailed understanding, detailed overview of the database design. So this entity relationship model, which we study in the chapter, is typically used to represent the conceptual design that is representing in the ER model. That includes a conceptual schema that includes or specifies the entity that are representing in the database. So this confirms that all data requirements are indeed satisfied and not in conflict with one another. That is the designer. So that may be he or she that design or examine the design phases, design concepts. Main focus on the point when describing the data and the requirements rather than specifying the physical requirement, rather than specify what to do, that is how to do. And a fully developed conceptual schema also indicates the functional requirements of the interquery. When I talk about the functional requirements, the user describes the kind of the operation that will be performed on the data. Example includes modifying, updating the data, searching, retrieving the data, deleting the data. That may be a modify, that may be update, that may be search out, that may be retrieve, that may be delete. And at this stage of conceptual design, the designer can review the schema to ensure that it meets the functional requirement, functional procedures. And whenever we are moving from abstract data model to the implementation of the database, that proceeds into final design phases. One in the logical design phase, the designer maps the high-level conceptual schema onto the implementation data model of the database design. That will be used, and this implementation is typically with the will be the relational database model, and this concept or this step typically involves what are the various conceptual schema that is defined with the ER model into the relation schema. And finally, the designer are using the resulting specific data schema in the physical design phase. When we talk about the ER model, there are the entities, relationship, and the attributes that may be specified with the file organizations or the choice of the index structures. Yes, when we talk about the entity, that refers to any identifiable item. That may be a person, that may be university, anything. For example, when you talk about the student that takes a course offering while the instructor teaches a course offering, teacher and the takes are the examples of a relationship. Yes, that is okay. These are also the entities, but when we talk about the entities, that main are the three parts. One is the entity, one is the relationship, one is the attribute. That's why it is known as ER model, entity relationship model. Yes, right. So for example, when you take about the university database, example of the entity includes instructors, that may be a student, that may be a department, that may be courses, that may be a course offering. Uh, a student have a different attribute, that may be a name, that may be a roll number, registration number. And when we design a database schema, we must ensure that there are two major drawbacks that is used. One is the duplication. This is the duplication part. Duplication means, for example, if I'm talking about the entities or if I'm talking about the rows, yes, exactly. Two rows having the same values. This is the major problem, biggest problem that is used in the information that receives a copy of the piece of the information. Because when we talk about the code that may run in the multiple semesters as well as the multiple times in a semester. So we refers to the e-search offering of a courses section. Next is the incompleteness. A bad design may also take several aspects, certain aspects of the enterprise difficult or impossible to model. For example, you have an entity that corresponds to the course offering without any entity to be corresponding to the courses. Then in terms of the relation, we have a single relation that repeats each and every information that the course offers. And avoiding the bad design is not enough. There are multiple good designs that we may choose. Let's continue with the session. So these are the two, we can say, the pitfalls or the drawbacks of the database design or when we design a database schema. One is the duplication, one is the incompleteness. These two must be avoided to take a good design for the better design. How this will be avoided? So we have to avoid these things kept in mind. The biggest problem that is used is that the copies of the piece of the information becomes inconsistent if the information is updated without taking the precautions to update each and every copy. Then incompleteness that may also take certain aspects of the enterprise difficult or impossible to model. Suppose that when we take about the entities that offering the without any entity corresponding to the courses, so equivalently in terms of the relations, we have single relation where we repeat all the course information once for each section that the course is offered. That will be able to represent about a new course unless and until the course is offered. And there are multiple, there may be a large number of the good designs from which we must choose. Now let's start with the first one, that is the ER model in details. So this was developed by the EF code. There is a person that developed this model, that is the ER model, EF code. That's why it is known as ER model. It was developed to facilitate the database design by allowing the specification of the enterprise schema. For example, if my specification, my requirement is that I have to build a model that represents the working of any program of the C language. For example, a while loop. That is also developed by using the flowchart or either using the ER models. So this describes or represents the overall logical structure of a database. How the data will come, how it goes to the table, how it modify, how we use the inner join, outer join, everything that is possible within the database. And this is very useful in mapping the meanings and interactions of the real-world entities. Real-world entities means live examples. And there are three basic concepts: entity sets, relationship sets, and attribute, as I told you earlier also. And in this diagram, in this model, we are using various diagrams, various pictures for representing entities, for representing relationship, for representing the attribute. There are multiple sets. So when we talk about the entity, then entity set, so that is the thing or the object that is different or differentiable from all other objects. For example, each person in the university is an entity that have a set of the attributes that have a very value that may uniquely identify an entity. Now, if I'm talking about the person ID or the employee ID, that is an attribute of a person. So one is the entity, that is a unique one. One is the attribute, that are the features of that entity. For example, the value 677899011 for the person ID that uniquely identify one particular person in university. In the same way, there is a course ID. In the same way, there is a customer ID, student name. Yeah, student name is not the same. That is not unique. It may differ. It may be same for the 2 students or 3 students and number of students. So entity set is a set of the entities of the same type that share the same attributes, attributes or properties, and that may be used with the university example that can be defined as the entity set instructor. Similarly, when we talk about the entity set student, that might represent the set of all the students in the university. And when we talk about the modeling of the process, we use the entity sets in the extension of the entity of the actual collection of the entities belonging to that entity set. That may be a disjoint, that may be used with all the entities, and that may be represented or that is mandatory represented by the set of the attributes. And attributes are the descriptive properties processed by each member of entity set. So one is the entity, one is the attribute. Attributes means the properties. And the designation of an attribute for entity set expresses that the database stores similar information concerning each entity. However, each entity have its own value for that attribute. Possible attribute of for example, of instructor, that is ID, that name, then department name, salary. In real life, we are also using further entities such as the street number, apartment name, postal code, country, but we omit example in simple because if I hodgepodge each and everything, that is not possible in the EF diagram. That is not user friendly, we can say. So each entity have a value for each of its attributes. For example, a particular organization instructor entity have a value 122 or 12121 for the ID, the value WU for name, and the value finance for the department name, 90,000 for the salary. This ID attribute is used to identify the instructor uniquely, since there are many more than one instructor with the same name. With a social security number of a person that is also unique, that also uniquely identifies the person in our general, and that may be a collection of the entity sets which contains any number of the or any number of the entities. Then there are two entity sets, for example, that is instructor and the student. This is the entity sets. Then relationship sets, that is an association among the several entities. For example, when you talk about the relationship advisor that associates the instructor Cat with the student Shankar, that use is an advisor to the student Shankar. And formally, it is a mathematical relationship on n is greater than equals to 2. So this will be used as in participation, that is the entity set, participation in the relationship set. It is also used in the ER diagram, ER schema, that represents an association between the named entity in the real world scenario. So this is the instructor table, this is the student table. So this is the relationship side advisor that makes the relationship among the instructor and the student. Now let's take another example. So a relationship may also have an attribute that is known as a descriptive attribute. That means gives a description of each and every attribute and every property. Now consider relationship set advisor with the entity sets, instructor and the student. So we could associate the attribute date with that relationship to specify the date when an instructor becomes the advisor of a student. When advisor relationship among the entities corresponding to instructor Cats and the student Shankar has a value 10,007. Which attribute? That is the Shankar's advisors on the June or 10 June 2007. This shows a relationship among the advisor with the descriptive attribute that is the date. We as a user going to describe the attribute date. And as a more realistic example of the descriptive attribute for the relationship, we are using the entity set student intersection which participates in a relationship set dates. Now we may wish to store a descriptive attribute grade with the relationship, whatever the relationship that we are using to record the grade that student got in the class. A relationship instance in a given relationship must uniquely identify the fiable from its participating entities without using the descriptive entities. So we are using the advisor for a student, we are using the single valued attribute date that can store a single date only. It is also possible to have more than one relationship set involving the same entity sets because we are using the instructor and the student entity set that participates in the relationship set advisor. And additionally, suppose each student must have another instructor who serves as a department advisor. Then both instructor and the student entity sets may participate in another entity set or relationship set that may be a department advisor. So that is a binary relationship. So we are using entity set project that represent all the research projects that must be carried out by the university. That may include the instructor, that may include the student, that may include the project. And to represent this information, we relate the three entity sets that represent the relationship set that is the project guide, which indicate that a particular student is guided by a particular instructor on a particular project. That is not captured by the binary relationship, but this is captured as or this is used as a guide for the different projects. Take 5 minutes more. Okay. One thing, yes, we're going to start after 5 minutes. That is the next topic, attributes. So till here, if any doubts, you can clarify the doubts. Yeah, we have finished with the entities, we have finished with the relationship. Just the overview of the relationship, but in detail we have studied about the entities. If there is any confusions, any doubts, you can clarify the doubts among the entities, relationships. Next is the attributes. We have discussed about the attributes in brief, we can say, not in detail. These attributes are nothing but the properties that must be accomplished by the entities. If I'm talking about a person that have different entities,